Let's look at the following number. Let's say 2 to the power 4. Now 2 to the power 4, I know that is 2 times 2 times 2 times 2, which is 16. However, if I want to know, I have 16, to what base, if 2 is the base, what power is that? Now I can see that by using guess and check. I can get that the same base and then I can find out what that is. So I can see that that is supposed to be x equals 4. If I have 2 to the power 4.5, I can't do that. I can't say 2 times 2 times 2 times a half 2. Alright, so what I'm going to do is I can do that on my calculator. Okay, so on my calculator, I'm going to say 2 to the power 4.5, enter, and my answer is 22.63. Okay, now if I wanted to know $18 is 2 to what power? I can't do that by guess and checks because I can't get x, I can't get this to the base 2 for any chance. And to do that, I need another function. And for that, I'm going to use my logarithms. And that is where logarithms comes from. So just as I can say 2 to the power 4 16, to what base do I have to put 2 to get 16? And I can find that by guess and check. It's 4. Just like that, I cannot do this the same way, and I need a calculator. So I'm going to use log. So all that we're going to do now is we're going to look at the logarithms. Logarithms, spelled something like that. Okay, so what logarithms are is the following. If I have n equals a to the power x, I can rewrite this saying the log, my base is a, to the n equals x. So we can see that logs is nothing else than the exponent. And that is what a logarithm is. So if I have to go back to this example, if I want to calculate what this is, I will say the log of the base 2 of 18 is x. So that is how you'd say, I need to know what the exponent is if my base is 2 to get an answer of 18. And that is what logs does. Now if we look at these, there's three very important things, or a few very important things that we have to know. First of all, we need to see that a must be greater, I'm going to write it here in a big red. A must be greater than 0. A must be greater than 0. And the reason for that is because when A is a negative, inside the bracket, it's going to be impossible to calculate. What we also need to know is that this whole thing is only defined when n is also greater than 0. And the reason for this is we know that doesn't matter if this is a positive value, doesn't matter to which power I put that, I will never be able to get a negative value. So 3 to what power is going to give us a negative? Doesn't matter which numbers it is, it's always going to be a positive number. So this is two of the things that you have to remember when you're working with logs. Okay, from this, there's three more things that we're going to, statements that we'll have to know. And I'm going to take it from these rules. The first thing is that we know that a to the power 0 is 1. Okay, so the first one of these statements that we have to remember is the following. The first thing is, if I write this in log form, log, my base is a, my exponent of 1 equals 0. So whenever we have a log of 1, doesn't matter what the base is, the answer will be 0. If we know that a to the power 1 equals a, let's write this in log form. I'm going to say for this second one, the log of my base my basis A of A must always equal 1. So the rule that we say if these two are the same, the answer must be 1. This is the reason. A to the power 1 equals A. So if you rewrite this into log form, it is clearly that these are the rules. The last one is just that we know that 10 doesn't matter what the power of x is, this can never be 0. This can never be 0. Okay, because it doesn't matter what I put in x. Clear, I'm just going to use this table to show you clear. So if I say table 10 to the power of x, enter, 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 enter. You can see if x is 2, 3, 4, y's value just get bigger and bigger and bigger and bigger. Can you see that? And if x value is getting smaller, it just becomes a fraction. 1 over 0, 0, 0. But it never can be 0. It's always 0 point something 1. So it can never be 0. Okay, and we also know, therefore, that a to the power x can't be 0. So what we also need to know is the third thing is if I write this as, let's just change this, a to the power x equals 0, log my basis a of 0, right, is undefined because it cannot be x. So if we ever have a 0, we just say it's undefined.